In this video, I'm going to show you how to find exact value of a trig function. So before we get started, let me give you a brief preview of which examples I'll be working on in this video. So these are the few examples that I'm going to be working on in this video. So go ahead and pause the video, work them out on your own, and then come back, check your answers along with mine. Okay, so before we do our first example, I do want to give you a brief review of the two special triangles that we're going to remember and a bit of info from the unit circle. So you have to remember the 30, 45, and 60 degree because those are the special angles that we often memorize in the unit circle. So for 30 and 60, you're going to create this triangle. So here's our right triangle, and across from 30 degree, the length is 1, and here we have 60 degree, and across from 60 degree, the length is square root of 3, which makes the hypotenuse 2. So this is one of the triangle you want to memorize. The derivation is really pretty. If you just open up any textbook, you will see how we have the length to be 1, 2, and square root of 3. Another triangle you want to remember is the one with 45 degree. So say here we have the 90 degree and the two corners we have 45 degrees. And across from both 45 is 1 and the hypotenuse is square root of 2. So these are the two right triangle you want to memorize and their degree measure along with the length, also the unit circle. So if you recall the unit circle, so I'm going to see if I can draw a perfect circle. So here's the unit circle, and we want to remember the quadrantal angles, such as 0 degree. So for the 0 degree, the coordinates are 1, 0, because the units is 1. And this point, which is according to 90 degree, the coordinates are 0, 1. And then this is 180 degree. We have negative 1, 0, and 270 degree. This is, the coordinates are 0, negative 1. And once we hit 360, we're back to the same point, 1, 0. So when you're evaluating a special value for such as, say, sine of 180 degree. So we know sine corresponds to the y value on the unit circle. So 180 degree, which is located right here. So we're looking at this terminal point, and we read off the y coordinate, which happens to be 0. So sine of 180 degree is 0. And one more, let's say if you want to evaluate cosine of 270 degree. So 270 degree is this point right here. So we're reading off the x-coordinate because cosine is the x-coordinate, so this would be 0. So these are the exact value. And of course, you can read off more from looking at the unit circle. Now let's just focus on those two right triangle and determine the exact value of a specific trig function. All right, so back to our first example. We want to know the exact value for cosine of 5 pi over 4. Now, of course, first thing you want to do is draw where is 5 pi over 4 is. So you could convert 5 pi over 4 into degrees to know its measurement, or if you want to just rewrite and then just draw the measure in radians, that's also fine. So I like to keep radians in radians, so I'm just going to rewrite it. So 4 divides 5 one time, so we have 4 pi over 4, which is 1 pi, plus a remainder of 1 pi over 4. So I just splitted the numerator and then just rewrite them. So now we have pi plus pi over 4. So that is 5 pi over 4. So now if I draw this on the xy plane, so here's our xy plane, pi is 180 degree, that's right here, and pi over 4 is right here. So that's where the angle is, 5 pi over 4. So we need to look for its reference angle. So the reference angle for this angle is going to be this angle right here, which happens to be pi over 4. So that is the reference angle. So this is pi over 4. Now to find the exact value, you construct a right triangle inside the xy plane. So here's our right triangle. Now I like to create right on the xy plane, but if you want to just pull it out from the xy plane, you can also do that. So the triangle we're looking at is this one right here, the 45 degree. So if you remember, pi over 4 is 45 degree. So that means the length are 1, 1, and this is square root of 2. Now because you're in the third quadrant, you have to remember your x is negative, your y is also negative, and the hypotenuse is positive. So that's something to keep in mind when you're beyond the first quadrant. Well, now we're ready to find the exact value. So cosine of 5 pi over 4 is equal to cosine of its reference angle. So we can say plus and minus cosine of its reference angle, which is pi over 4. Now, of course, you can remember using the plus and minus from the acronyms. We often remember ASTC, which will tell you which ones are positive, which ones are negative. So, or if you want to just ignore that, you can also ignore it just by looking at the right triangle. We know cosine is adjacent over hypotenuse. So across from theta is our opposite. This is adjacent and this is hypotenuse. So cosine pi over 4 is adjacent over hypotenuse. So that will be the exact value. And you see how we got the negative sign just by labeling the right triangle and giving its negative symbol because it's on the third quadrant. Or if you were to use ASTC, only tangent is positive on the third quadrant and cotangent. So that means cosine will get a negative sign. So you can also think of it that way. Now, another thing to remember is sometimes you might want to rationalize your answer. So you can also do that here since we have a radical in the denominator. So go ahead and multiply on top and bottom by radical 2. So we can also have our answer as negative radical 2 over 2. So that would be the rationalized value. Okay, now let's take a look at our second example. So here we want to evaluate tangent of 135 degree. So again, we're going to draw the angle. So here's our XY plane. 135 is right over here. So that's where this angle terminates. So now I'm going to create my right triangle and figure out what this angle measure is. Now, of course, that's going to be the reference angle. So the reference angle for 135 is going to be 180 minus 135. So that would give us 45 degree. So that is the reference angle. So now the triangle that we're going to draw is the 45, 45, and 90. So that means across from 45 is 1. This is also 1. And the hypotenuse is radical 2. Now, because you're in the second quadrant, x is negative, y is positive. So let's keep that in mind. And now we're ready to read off what is tangent of 135 is. Well, we know tangent of 135 is equivalent to plus and minus tangent of its reference angle, 45. So we know tangent is opposite over adjacent. So across from 45 is opposite, and this is adjacent. So we have 1 over negative 1, which is simply negative 1. So there you have the exact value for tangent of 45. Now again, you can check your sign if it's correct or not by remembering the acronym ASTC. So S meaning sine and cosecants are positive. So that means the remaining trig functions will have a negative value. So it makes sense to have a negative sign in front of 1. Okay, so let's get ready to do the next one. Sine of 11 pi over 6. Now again, because it's in radian, I like to rewrite them. You can rewrite them with me, or you can just convert it to degrees. So 11 pi over 6, I can rewrite it as 6 pi over 6 plus 5 pi over 6, because that's 11 pi over 6. And then 6 pi over 6 will simplify to pi plus, and then if you want, you can rewrite 5 pi over 6 as 3 pi over 6 plus 2 pi over 6. So just keep rewriting until you know how much the measure is in degrees. So I rewrite 5 pi over 6 as follows. Now simplify them. So we have a pi, which we know 180. 3 pi over 6, that simplifies to pi over 2. And then 2 pi over 6 simplifies to pi over 3. Well, these are some angles that you should be familiar with in degree measure. This is 180, and this is 90, and this is 60. So now we're going to sketch 180, 90 plus 60, because that is 11 pi over 6. So here's our XY plane. So 180 is right here, 90 is right here, and then 60 is just gonna go a little bit more. So we terminate on the fourth quadrant. So there you have your picture. So that means we're going to construct the right triangle on the XY plane, but we need to find the reference angle. So let's fill in. What is the reference angle? So this is, so the reference angle is going to be 2 pi minus 11 pi over 6, because 2 pi will complete the entire circle. And by removing 11 pi over 6, we get that remaining piece, which is the reference angle. So this would give us pi over 6. So this angle we're looking at is pi over 6. Pi over 6 is 30, so we're going to construct the triangle. Across from 30 is 1, and then that means this angle is 60. So across from 60 is radical 3, and then this length happens to be 2. Okay, so now we're ready to read off the exact value for sine, but let's fill in the symbol plus and minus sign. So in the fourth quadrant, only the y-axis is negative, so 1 will be negative, and radical 3 will be positive. Hypotenuse is always positive. Okay, so sine of 11 pi over 6 is equal to sine of its reference angle, which is pi over 6. And of course, because we're in the fourth quadrant, you want to put in plus and minus sign. So sine of pi over 6, sine is opposite over hypotenuse. So that would be negative 1 over 2. So that will be the exact value for sine of pi over 6 on the fourth quadrant. Again, if you want to verify that you have the correct symbol, you can rewrite ASTC. And only cosine is positive on the fourth quadrant, so it makes sense to say negative 1/2 for sine. All right, now let's take a look at this example. Now this one, we have a negative angle, which means we have to draw the angle going clockwise direction, or the other option would be to find the coterminal angle because they terminate on the same quadrant. So if you need to review coterminal, maybe this would be the right time to do that. So let's go ahead and find the coterminal angle for negative 225 degree. So for coterminal angle, what you do is you add or subtract 360. I'm going to add 360 to it so that I get an angle that is positive. So if I do 360 minus 225, that would give me positive 135 degree. So negative 225 and 135 are coterminal. All right, so now we're ready to sketch them. So we're going to draw 135 because that's a positive angle. And we know 135 terminates right here. So there you have the angle. Now let's draw our triangle right in here. So we have our right triangle. So if this is 135, that means this is 45. So that is the reference angle. So we're drawing the 45, 45, 90 triangle. So that means across from 45 is 1, 1, this is root 2. So because we're on the second quadrant, x is negative, y is positive. All right, so we took care of all of that. Now we're ready to find the exact value. So sine of negative 225 is exactly same as sine of 135. So we wrote it as a coterminal, and now we're going to use the reference angle to find its exact value. So sine of 135 is equivalent to plus and minus sine of its reference angle, which is 45. And now we read off from our picture, sine is opposite over hypotenuse. So this across from 45 is opposite. This is hypotenuse. So we have opposite 1, hypotenuse, radical 2. So that would be our exact value. And again, we can check with ASTC to make sure we have the right value. ASTC, which tells us sine is positive on the second quadrant, so this makes sense. And if you want to rationalize this, you can multiply top and bottom by root 2 over 2. So you have root 2 over 2 as the value. So any of these should be acceptable. All right, so let's take a look at our last example, secant of 600 degree. Now again, this is a huge angle, so you want to make sure that you find its coterminal angle, or just draw it and then figure out its coterminal and the reference from there. So why don't we go ahead and do that? So 600 degree, if I were to draw it, so 600 degree, so if I go around one cycle, that's 360. And then if I go around more from here, so about 300, let's say, so I can go around another 240, which will lead me right here. That would be my 600 degree. So 600, we went around one cycle, and then 240 more gave us 600. Now, how else can we do this? Well, we can do this by rewriting 600. So we can rewrite 600 as cycle of 360 plus 240. So there you go. Every time you have 360, that's equivalent to 0. So 600 and 240 are coterminal. So 600 and 240 are coterminal. So now we're ready to use the coterminal angle to find its reference angle and then draw our right triangle. So here's the right triangle. And since we went around 240, which was this piece right here, that means the reference angle is going to be 240 minus 180, which would give us 60 degree. So our reference angle is going to be 60 degree. So the triangle we're going to draw is 30-60, since that's the one we're looking at. So I'm just going to fill this in. This is 60, so this is 30. So across from 60 is radical 3. Across from 30 is 1. And then this is going to be the hypotenuse. And because we're on the third quadrant, we know our x is negative, y is also negative, hypotenuse is always positive. Okay, so now we're ready to figure out what is secant of 600. Well, 600, we wrote it as its coterminal, so secant of 600 is equivalent to secant of 240, which is equivalent to plus and minus its reference angle, which is now 60 degree. Now, if you recall, secant is a reciprocal function. It's a reciprocal of cosine. So if cosine is adjacent over hypotenuse, that means secant is hypotenuse over adjacent, just the reciprocal of cosine. So we're going to read off, so we know this is opposite, this is adjacent, and this is hypotenuse. So secant is going to be hypotenuse over adjacent. So this would be negative, this would be 2 over -1, which simply is just -2. So that would be the exact value for this. Okay, so this is it for today. I hope all of this makes sense. So I'll see you next time.